Okay, clear? Can we move to the next one? Now, moving control volume. Yeah. So you will have to change this with W. Okay. Sometimes this is the problem. Sometimes you have to maintain this one same. Like in the case of the turbofan engine, right? This is your V out. This is your V in. In this case, okay, in this case, when this one is moving, this V in has to be V. But for the Pelton, this one, both V in and both V out will be changed into W. Why is that? Because
the volume is moving.
The volume is moving, and it is not going, like in the case of turbine, the turbine is moving, right? So the velocity relative between these two will remain constant. So you will not feel the difference on it. But in this case, it is a jet striking it. Okay? You know Tai Chi?
Yes.
How it works? When someone wants to hit you, you follow the flow. So you will not feel the... Yes. Same goes for this one. When the jet hit it, and it's stationary like that, the velocity it feels is, let's say 10, it will feel 10 meters per second. But what happens if it moves? If it moves at 10 meters per second, which means it will not feel anything. Okay, Catherine, start to watch this. This thing hitting at 10 meters per second. So if your hand is moving at 10 meters per second, you feel nothing. Right, 0. But if you move at 8 meters per second, you will feel 2 meters per second. Okay, if you are stubborn, you stick to that location, you will feel the full force, 10 meters per second. So now the question is, let's see what happens if we are stubborn and we follow the flow. Okay, let's take a look into that. Now first, we need to draw our control volume with all the properties working on it. Do we have pressure force here? Do you think?
Yeah.
Pressure force? Sure, Farhan? Do you have pressure force here? No. Why no?
Atmospheric.
Yeah, all is exposed to atmospheric condition. So at point 1, we will have it atmospheric pressure. At point 2, we will have it atmospheric condition. So where is my atmospheric condition? Okay, now you get the Pelton turbine. So why the Pelton turbine look like this? There is a story behind it. Hopefully Dr. Chim will tell you how. Next semester, if you pass this course. Okay, passing this course is very tough. Okay, this is your water jet coming in, and this is coming out at some angle 45 degrees. 45 degrees. Okay, there is something that you need to look into very, very closely. One, the jet is symmetric, which means the flow over here will be half mass dot in. Over here is half mass dot in. This one 45 degrees, this one has to be 45 degrees. So you don't need to do it outlet 1 and outlet 2, no need. So you just combine them as m dot. Okay, doesn't really matter. Then the fluid speed remain constant along the fan surface. What does it mean? It means V in, no changes. So don't try to find, then what is my V out? No need to worry. V in equal to V out. Your V out is also your V. Okay? And from the mass continuity, you know that M dot in will be M dot out. As simple as that. So, what is the X component? We got Fx is equal to M dot in, V in, positive or negative? Ladies and gentlemen, negative, V in. Let me do this. This is negative, this is positive. Plus M dot out, V out. Okay, M out.
Negative.
Positive or negative? Positive. V out. Positive or negative? Sure, positive. Where is your X and Y? Me, X, Y. So your V will be? V will be negative. Okay? We are talking about X. Now, I didn't put it there. We are talking about X. So it has to be in the X direction. In the X direction. So V out, X is equal to V out, blah blah blah, 45 degrees. Sine or cos?
Cos.
Cos? Sure?
Yes.
You have this. This is your Y. This is your negative X. This is your T. This is your theta, right? So when you are talking about X, it has to be cos. Okay? So we know that M dot in is equal to M dot out. Kan? So you got M dot in, V in, minus or plus? Plus. Because this one minus, this one minus. So I got minus here. Is that okay? I put in the front. Equal to minus. I put in the bracket. V in plus V in cos 45 degree. Why suddenly become V in? Because V out is equal to just the direction is okay. Okay, ladies and gentlemen. So you get rho A V in square 1 plus cos 45. Simple. Boleh ya? So, what happens if I give you the problem of anchoring like that? Same. But in this case, if you have that, you see that this one is on the positive. Okay, so this one will be
Okay, sir. For the M out here, tak payah nak kali 2.
no need. Half 2 times half. Okay. Now if this one this one negative kan? If the shape of the Pelton wheel is like that, I'm talking if, if it is like this, so the flow is split into two, but it will go that way. What happened? You can still see that this one is V in, kan? This one V in. Only now the direction is different. So you got Y, you have X, and this one will be your V in or V out. Okay. So now in this case, this V out become positive. Positive, you got positive. So this one negative, positive. The opposite direction. So the force will be bigger or smaller?
Bigger.
Smaller.
So then for that one maknanya ada dua V out right?
In this case,
Yeah.
same lah. Because this one symmetric. Symmetry means this one is half times 2, 1.
Angle different?
Kalau angle different, you have to calculate differently. If the angle is the same, you can combine them.
Yes.
What happens if this one the angle is 30, this one the angle is 45? So you need to, this m out become half m dot in v out times cos 30 plus half m in cos something. 45. Clear? Okay, last one. So this one done, yeah? You can calculate it. Last one. What happens if it moves to the right with 3 meters per second? Okay, as I told you before. Mim is there. That's me here. Bring the water jet. Okay? And he spray her at 10 meters per second using the fire factor hose nozzle. If Mim is just stay like that, you got 10 meters per second. Now Mim is smart. She's a smart girl, so she move as fast as possible, and the fastest she can move is 3 meters per second. 3 meters per second. So from the point of view of Mim, what is the velocity of water coming in? 7. Why? Because you know V is equal to W plus V CV. So now you need to find W, which is equal to V minus V CV. This is your V, which is 10 meters per second, and then your VCV is 3 meters per second. 3 meters per second. So your W will be 10 meters per second minus 3 meters per second. So you got W is 7 meters per second. So you replace now this V with W. You change the W, then you get your FA. Okay, the last question. Okay, this last question, I will not explain it in a detail. What do you get is this. This one you know. This one known. What do you need to find is ni and D. So how do you get it? You plug in this. You know this row A. Okay. This one A in V in will become Q times V in, right? And this one, because this will be the same, so it will be Q V out. Rho is the same. Okay, so you will have rho, no cancel, sorry. Rho Q V in, rho Q V out. Okay, the difference between rho Q V out minus rho Q V in will be equal to FA, and FA you know. Okay, your FA is 1.3 kilonewton. Okay. Assume the inlet and outlet jet water are free jet, which means pressure is equal to atmospheric pressure. Okay, so there is no PA1, no PA2. So you can calculate the P out.
FA is 1.3, sir.
FA is 1.2.
FA can the anchoring force.
Yeah, that one is anchoring force. This one we call it FT, transpose. Okay, if you do that, you will get that because you know you will get FA is equal to, okay, quickly, someone is waiting there. FA is equal to rho Q P out minus P in minus the direction you check later on, because you remember P in is on the angle. Okay, so you need to take that into account. And then the relation between P out and P in is that A in, P in, A out, P out. So So you will end up, this one will be on either V in or V out. You have FA, you get F in. You get F in, you get F out. Sorry, V out.
How will the angle change the
The angle will change this. Okay, because the area is like that. The area is angle. Okay, no question? No question, so we finish with the linear momentum equation.